Hey, folks. Excellent job yesterday with factoring these trinomials, right? Man, that was a challenge, and a lot of you guys stayed focused. Bam, knocked it out. If you're not there yet, you had a difficult time yesterday, don't worry. There's nothing wrong with you. First time, a lot of us see this concept. It's kind of tricky, right? So let's do a quick review. What we did was we took the 18 that was sitting right here. We took this number and we put it in the table right there. And we took the middle coefficient and we put it on the right side of our table. It doesn't really matter. I noticed some people were switching these around, but I'm going to keep it like this, I think, forever, just so that it doesn't confuse anybody. We're looking for the two factors that multiply to give me this number and add together to give me that number, right? So we said yesterday that works because when you're using the distributive property, you have to multiply the outsides together and the insides together. And when you multiply the outsides together, you get 2x. When you multiply the insides together, you get 9x. Those two have to add together to give you 11x, right? And the last multiplied together have to give you 18. So it didn't take me that long to explain that process, and a lot of you guys knocked it out. Today, it's going to take me a tiny bit longer to explain the process because it's a little more involved. In day two, we're factoring with a leading coefficient not equal to 1. So we're going to just put this down. Leading coefficient not equal to 1. So we're adding this to yesterday's notes. Leading coefficient not equal to 1. So this is section 11.6, by the way. And I just want you to add some stuff to yesterday's notes if you have space. All right. So look, first, let's just make it super clear. Where is the leading coefficient, right? It is the number in front of x squared. The number, put that down. The number in front of x squared. Okay, so I'm just going to draw a little arrow to this situation. All right, that's what we want to factor today. Again, to make it crystal clear, when we are completely done, we're going to have two factors sitting right here. Now, today's going to take a little bit more work, so maybe it was foolish for me to put my factors down right there. But I think what I'm going to do is I'm going to try to squeeze the work down here, and then I'll put my answers back up in here. All right. All right, here we go. And I'll explain why this works here in just a bit. But first, let me just show you some of the similarities. All right. Well, we're still going to put a little table down. So I'm going to put my table up here so I give myself plenty of room. You're still going to take the 34, and the 34 is definitely going over here. Come on. 34 is going to go over there on that side of the table. So 34, the middle coefficient, is going on the right side of the table. The difference here is I don't just take 24. I got to take 5 times 24. Now, a little alarm is going off in my head. I forgot to mention one thing. Okay, let me just put the 5 times 24 down, and I'll put it right over here. Okay, so I want to do 5 times 24. That gives me 120. I'm going to put 120 right there on that side of the table. Okay, so multiply those together. Add that to your notes. Multiply. Okay, well, the alarm that was going off in my head is I should have checked to see if there's a common factor between all three terms. If there's a common factor, you want to do that first. You want to factor that guy. You want to distribute that guy out to the front. Like, let's say all of these were divisible by 5. Well, shoot, man, I just changed my complicated problem into a leading coefficient of 1 problem, which we did yesterday, right? So we want to look to see if you could divide everything by a number. And I'm going to do an example like that with you here, right over here, right? See how they're all evens, 4, 22, and 10. So I divide everything over here by 2, or maybe even 4. 4 would divide into all of them, but I can see that 4 is not going to divide in all three of those numbers. Anyways, we'll get to that one in just a bit. So with this one, I noticed before that there were no common factors. So I'm going to take and just go 5 times 24, write that number down there, and I put my 34, the middle coefficient, over here. I want to find the factors that multiply to give me 120 and add to give me 34. So that's exactly what we were doing yesterday. Once you get to the table, you're doing what we did yesterday. So let's try an easy one, because I think sometimes people think I got to get the right one right out the gate. Well, I see 10 times 12. 10 times 12 is definitely 120, right? But when I take 10 plus 12, I get 22 when I add those together. Nah, that's not right. I need 34. So let's try. Oh, hey, I got it. How about 20 times 6? 20 times 6. Well, I add them together, 20 plus 6, that gives me 26. Shoot. Okay, let's go up another 10. I think 30 goes into here, doesn't it? So 30 times 4. Oh, look at this. 30 plus 4 is 34. Hey, those are the ones I want, okay? So it's unfortunate that I can't just put 30 and 4 in here. Let me just put it down. You don't write it, okay? Because I can easily undo this. If I put 30 and 4 here, well, what's going to go in these first two spots? Before it was super easy. You just put an x and an x because we want those two to multiply together to give us, it's not x squared though, it's 5x squared. So wouldn't it have to be 5x and an x? And do you see how, like, when we multiply these together, we get 20. We multiply those together, we get 30. That's not giving us the right numbers. That's not giving us, right? That's giving us 50x. So something's not quite right. So let me undo all that stuff I just put in my parentheses. I'm not quite there yet. This doesn't tell us the numbers that go here and here. What it tells us is what the polynomial looked like after it had been distributed. All the distributive stuff had happened after we multiplied everything out. It all looked like, okay, so I'm going to put over here equals 5x squared plus 30x plus 4x plus 24. This is the way it looked after it got completely distributed, like boop, 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 all the multiplication happened, okay? So in other words, it's telling us, how should I say this? Well, I'm just going to leave it like that. It's telling us what everything was after it got all multiplied together, all right? So what we need to do is we need to convert it back into this form. And look how there's 4 terms, 1, 2, 3, 4. This lends itself to factor by grouping really well. So what are the common what are the common factors between these two terms? Well, there's a 5x in both of them, right? So this gets a little cumbersome to write 5x squared, 30x, and write the prime factors down. Don't you agree? This one is 5x times x, and this one over here would be 5x times 6. Do you see how they both have a factor of 5x? So I'm going to pull that 5x out, distribute it out front, and I'm going to write x plus 6. I'm going to write what's left of my 30x and my 5x squared if I divide each one of those by 5x. Or if I distribute a 5x out front, I would have an x plus 6 left over. So I put x plus 6 down, okay? Here comes the next two terms I'm going to group together. So I can see, personally, I can see that 4 divides into both these, evenly, right? So 4 is a factor of 4, obviously, and 4 is a factor of 6, right? 4 times 6 gives me 24. So what I want to do is I want to factor or distribute that 4 out front, and I'm going to put x plus 6 down. Now, in factor by grouping, you're looking for common factors in those two places, and they're the same. They're the identical to binomials, right? So that means that one of these factors over here is x plus 6, and the other factor is 5x plus 4. So I'm going to put 5x plus 4 down. That's how this factoring technique works if the leading coefficient is not 1. So before I do question number 3, I want you to try question number 2. Okay, so I got question number 2 down here. 2x squared plus 19x plus 24. You try that one, put the video on pause, then come on back and follow me on question number 3. All right, thanks, folks. You can find question number 2, in McGraw-Hill if you were like, wait a minute, you pushed it off the screen, right? So here I go on question number 3. How does this one differ from that one over there? Well, it has a common factor in it. You can see this one's even, this one's even, this one's even. So I could pull out or distribute out a 2. So 2 times what would give me 4x squared? Well, it'd have to be a 2x squared here. 2 times what would give me 22x? It would have to be an 11x right there. 2 times what would give me 10? Oh, that would have to be a 5, right? That's one way to distribute a 2 out. Another way is to say, well, 4 is 2 times 2, 22 is 2 times 11, and 10 is 2 times 5. So I'm pulling that common factor of 2 out and putting it right there. And the remaining factors that I couldn't distribute to the front have to stay inside. See the 2, the 11, and the 5, right? Now, why is there an x squared, an x, and just a constant over here? Why didn't I factor something else out? Well, there's not an x factor in each one of those terms, right? There would have to be a common x factor for me to say I'm gonna put a little red underline under it. I can't put a red underline under every single term because they don't all have an x in them, right? All right, woo! Here we go on this new or slightly new process. We're gonna put down a table. And I'm definitely putting 11 on the right side of my table. That's the middle coefficient, right? Okay, now I'm definitely going to multiply my 2 times my 5. So this is a 2 times 5, and I'm going to put that number right there. That's a 10. Okay, all right. Now, you don't need to put down wrong numbers here. You don't need to put down wrong factors like I did over here. But when it's a big number and you're not sure, it's best just to find any factors. It kind of gets your brain saying, hey, I can do this, right? Well, I can see right here that 1 times 10, I think, are the ones that I want because when I add 1 and 10 together, I get 11, right? So the next thing I do is I come down here and I don't want to lose my 2. So I'm going to put down 2, and then I'm going to put a parenthesis down, and I'm going to put down 2x squared. Okay, so I'm going to break the middle term up right now into 1x and 10x. So I'm going to put down plus 1x and 10x. And then I'm going to take my constant, right? And I'm going to put that right over here, plus 5. Do you see that? See where I'm taking my 5, like my 24 over here. I'm just checking, make sure I put my notes down right. See my 24 right there? So I'm putting the 5 right at the end. So it's really only these 2 middle terms that we're separating, and we're separating them based on these 2 factors right here. So here we go. I'm going to go 2 times, and now I've got a group. Let's see, what do these 2 have in common? They have an x in common, right? I'm hesitant to do this, but I'll do it real quick. 2 times x, okay? And this one over here is just an x, so I could underline, in red. Okay, so this is in common between 2 of them, so I'll put an x down like that. Now what's left is 2 and x, right? So I got to put 2x right there. What's left over here if I factor out an x? Well, this is like x times 1. There's always a 1 that you could put there. So I'm going to put plus 1. Okay. All right. Now let's see what's in common between the 10x and the 5. Hopefully you can see that's a 5, and I don't need to write my factors down. So I'm going to go 5. I'm going to distribute a 5 out. There'd have to be a 2x right here if we're going to get a 10x. Then there'd have to be a 1 over here if we're going to get that 5. The 5 can't disappear, right? All right. Hey, we're almost there. Don't worry. We're almost done. So my final answer, I'm going to kind of move this over here a little bit because I'm squeezed over there against that side. So I've got my 2 still. I got to keep that 2 with the problem, right? And then I've got my x and a 5. Well, first let's take out the common factor here. 2x plus 1. So I'm going to put 2x plus 1. And then I'm going to collect the stuff that's left over. The x is left over and the 5 is left over. So I go x plus 5. All right. All right, now you try problem number 4. Put the video on pause. You try problem number 4, and we're going to do these 2 in class together. All right. Hey, thanks for watching the video.